JFix and a new video, and in this video I'm continuing my repair journey and I want to look at repairing power supplies. Obviously there's some dangers associated with repairing power supplies, so I'm looking at the safety and putting together some tools that's going to allow me to work safely and diagnose simple faults on power supplies. So with that being said, let's get straight into it and I'll show you what I'm working on here. Now, over on the bench here, we've got some items, some new things that I've picked up off AliExpress, some bits that I've managed to get off eBay as well. The AliExpress parts that I've got, I'll be providing links in the description if you're interested in any of those, because I've got some really useful and quite reasonably priced tools on here. But yeah, we're going to be looking at trying to repair power supplies. And when I speak about power supplies, it's things like this. Like the power bricks, where you've got a 240 volt input and various whatever DC output on there. And when it comes to working on a power supply, these things can obviously be quite dangerous. And as somebody that's new to repairing them, it's important just to, before jumping into repairing something like this, you really understand the safety involved. And I'd also appreciate if you've got any advice to leave comments in this video, and hopefully I can learn together as well reading your comments. But yeah, let's get to it and I'll show you just briefly what I've got, and then we'll get to these more detail. Now, first up on my desk, I've got this UK wall plug just mounted in a little box that I can move around on my desk, and that's ideal for plugging devices in that I'm testing. That is until you plug in something unknown in there. Now, if I've got some games console with some dodgy power supply or something like a dodgy power brick and I'm going to plug it in there, this is going to be dangerous for my house electronics. If something's shorted when I plug it in there, the first thing it's going to do is trip power to the workbench, trip my main RCD on my consumer unit, and it's going to cause problems, especially because I'm recording a video. All the lights are going to go out, and I'm going to lose my footage that I'm using to record, so not good at all. So what can we do to get around this problem? So the solution to this problem is quite simple, and lots of people do this, and it's something called a dim bulb tester, people refer to it. But all it is a light bulb that you wire in series with your socket. So if you plug something shorted in there, instead of it tripping your electrics, all it's going to do is light up your bulb. So it's super simple and quite cheap to put together. So to do this though, the only problem is it's quite hard to find these old incandescent light bulbs in any shops. I had to buy this on eBay because they're being phased out, especially if you want a 100 watt. You'll only be able to find a 60 watt mostly in shops. So I picked up this. It is orange, but I quite like the orange and it won't affect it. It's still going to do the same job. I also picked up a bulb holder. Now, my idea is I'm going to put this bulb into the bulb holder and I'm going to be able to mount it on the top of this socket here because there's a place to feed the cable, but we'll go through doing that. And the beauty of this is that I can use a switch on here to switch it on and off in this holder. So I'll be able to have the bulb engaged in the circuit, and once I know the item is good, I can just switch it back off again and use the socket as normal. So we'll wire that up a bit later on. And I've also got a socket on here, just old one, that I'm going to actually put a full short on this socket and plug it in, and we can demonstrate if this works well or not. Now, while we're on the subject here, there are a few more things that I don't have yet that I wish to get in the future. But this is going to get me going, just so at least I don't blow my electrics up. But in the future I'd like to get something called a variac. Now what this will allow me to do is adjust the voltage. So instead of just putting the full 240 in, I can lower the voltage and rise it up gradually. And I believe if I'm going to get involved in doing things like any TV or amplifier, these type of repairs, some things have like a initial rush of current going into them when you power things on, so that can also help that you can bring things up gradually and start to warm up the components inside on the motherboard before just banging it on full straight away. So that's something I might look at getting. Now the other thing I want to eventually get is the isolation transformer as well. Now this has been recommended as something else that's good for safety, because if you especially if you're going to work on things live, it gives you that extra layer of protection. And basically what I understand it to do is it completely isolates the thing you're working on from the rest of the circuits in your property. So you've got a different ground and things like that running through this isolation transformer. Especially if you're going to use things like oscilloscopes, and it can prevent accidents and things happening in damaging your equipment or damaging yourself. So that's certainly something I'd look at getting in the future. But that being said, I don't plan on working on anything live to start with, not until I've got some experience. So let's move on to that now, and I'll show you how we're going to try and fault it using a few tools that I've got here. Let's talk about these two tools now. These both I picked up off AliExpress, so I'll post the links for these two. Now, these are capacitor discharge tools, and from what I understand, when you plug your voltage, your mains voltage, into a board like this, it's going to charge a big capacitor in the circuit like that. Now, there may be other various capacitors, like a capacitor on the output, but on the main side there's going to be a large capacitor, and this can hold a really large amount of voltage in here and can give you a nasty shock if you were to get in there while you're faulting and touch the contacts. So just having your power supply disconnected isn't good enough. You do also need to be able to remove the voltage from inside this capacitor and the electrical charge inside it, and that's where a tool like this is going to come in handy, because it has two probes and I can get into there and short out the capacitor, and I believe this is going to give me a visual indication. We'll try that in a second. And the second tool that I've got allows you to just put multimeter probes in there, and that might give you a little bit of more flexibility in different circumstances where you can't get this one in, and it also gives you a readout. So I'm going to test those ones as well a bit later on. I'm just showing you everything first briefly, and we'll test everything after we've gone through these. So the next thing I picked up off AliExpress is this, and it's a Octocoupler Tester with the 4 feet on the end here. So from what I understand with this, and by the way, somebody recommended that I pick this up on one of my comments. I can't remember who it was, but thank you for that. I appreciate that. So I did pick it up indeed. On these power supplies, you're going to have, from what I understand, a hot and like a hot live section, and then like a hot and a cold section, where it's electrically isolated from the AC input and the DC output. And there'll be a section in your power supply where, you know, there is no connection between the two. All you'll have is the transformer in there and some octocouplers which we can see in here. They are the way that it uses to communicate. So what I believe is on one side of the octocoupler is an LED that's able to flash, and the other side is, I think it's something called a photo transistor that's able to communicate within that chip, and both sides are able to talk to each other. So yeah, to be able to test that, I'm not sure if there is a way to do it on your multimeter, but as I say, it's not an electrical connection. So with a tool like this, you'll be able to go in on the 4 probes and test it like that. I'll give that a try a bit later on, but I want to show you the next thing that I've got. And by the way, it does have a USB-C charging port, which is always nice. We don't like micro USB, so that's another win for this one. And the last new item that I picked up is the curve tracer. Actually needs that peeling off. Now, this is a nice little unit. Again, USB-C port, and let's switch it on. Switches on quite quickly. Now, from what I understand with this tester is that it's got a X and Y axis in here, similar like an oscilloscope screen, but but it's on the X and Y axis. So instead of like voltage over time, it's voltage and current on the axis on here. But what this is going to allow me to do is, when I've got a power supply, hopefully what I can do with this is test these components while they're still in circuit. Because a power supply is obviously made up of quite simple components really. You've got diodes, resistors, capacitors, MOSFETs and rectifiers, things like that. All things which have got electrical characteristics that could be tested with this in circuit. So if I'm not sure about something, hopefully I'll be able to probe with my curve tracer and get a good idea of whether or not the component is okay before removing it from the board. That's going to allow me to work a lot safer, because what I don't want to do is try and connect and work on a power supply live and checking around for voltages, things like that. It's going to be much safer to work without this board powered on. So that's my idea, and we're going to test that to see how well it works. And I believe it specifically works very well if you've got two similar power supplies, and I think that's what I'm going to be aiming for, especially as I'm new and I might not have schematics and things for power supplies like this. If I've got a known working power supply and a faulty one, I can have them side by side, and I've got two channels on my curve tracer here, and I can probe them both at the same time and compare them instantly between each other, and that will make it quite easy to pick out different faults on components. Right, so let's get into this dim bulb tester. I've taken this socket apart in here, and I've got my input on here with my live, neutral and earth, and what I've already done is cut a hole and mounted the bulb holder in the top, and that's completely solid now. And this is the internals of the bulb holder, and again we've just got a live, neutral and earth, and that's going to slot in there, and the cables are going to feed through the hole. So what I've done is the live and the neutral I have wired just with the brown wires. I'm going to disconnect this one and connect one end in there, and then I just need to join these two together. And I'm also going, because it is a metal, I'm going to also ground this as well into there. So let's get on with that now and get that wired up. Right, there is a holder clamp just to clamp this down. In fact, I think it's this one first that goes on. Nice. This one's just the ring if you're actually going to put a light bulb shade on. One thing that's not that obvious is which way on this bulb holder is on or off. There's no markings on it, so I better just confirm that. So I've got my multimeter set to continuity, and let's go on both ends of the wire coming from the bulb. This is one end of the wire. Let's see if I can get in. Yeah, I go in like that. The other end goes to here. Okay, nothing. Let's try and switch it on. Yeah. So when I switch it to the right, the bulb is on. I think I'm going to make a marking on there, just so I know that for future use. Right, I think we're all set up now, ready to test. So I've just put some labels on so I don't get mixed up. I know which way the bulb is on and off. And I've connected my live from the bulb just with a Wago connector. So let's put this back together and give it a try. Okay, so we're set up ready to test. I've powered up my socket and we're on. It's flickering on the camera but not in real life. And I've created a socket here, and this is a direct short now between the live and the neutral. Let me put the cap on there and we're going to see if this works. Okay, so the bulb is definitely in the on position, so fingers crossed, if I switch this on, it should illuminate the bulb and this is the full short on here. So slightly nervous, but let's give it a go. And here we go, the bulb is on. So I'm really happy with that. That's worked out perfect, and even with the full short on there, replicating, you know, plugging in something dodgy with a dodgy power supply, it's still protected. My electronics didn't trip off on the workbench, and my consumer unit didn't trip, so I was still able to use it. Now this is a 100-watt bulb, and I've also got a 60-watt bulb as well, so I've got the ability, if I want to, quite easily just to swap that out, and say that 100 watts quite high resistance, and if I wanted to test something, you know, it's drawing quite a small amount of current, I can easily swap that out and put like a 60-watt bulb in there. So yeah, let's move on to the next thing. Back onto the Octocoupler Tester now. I've had it on charge with the USB-C. If you buy in this from AliExpress, there's two different variants. One with an internal battery, so I recommend you get that one, and then you can just hold down this power button on the side, and the red light will illuminate to indicate it's on, and you've got the light in here, that is the test light. So all it is it will light up with a green LED if it's working, and you've got the 4 pins on here which are perfectly sized for testing those octocouplers. So let me see if I can get onto one of those and just show you that it's working. You see that there? The green light indicates that the octocoupler is working fine. Super simple, nothing to it, but remember to switch the unit off once you've finished. I don't know if it auto switches off or not, but we'll save the battery now it's fully charged. And yeah, dead quick, simple to check those. Right, let's give these capacitor discharge tools that I've got a go now. So I've got my power supply hooked up. I'm going to turn it off now, and let's measure the voltage that's in this capacitor currently. So we've got 329 volts in there. So let's see if this can indeed discharge the capacitor. So we've got an indicator light, and now it went green. So it does have a visual indicator in there. Let's measure again on that capacitor. Yep, just 8 volts. So there's basically nothing. So that worked really well, actually. I'm impressed with that, and it gives you the little green indicator once it's discharged. It goes red to start with to show there's voltage in there, and then it turns to green. Right, let's have a go with discharge tool number 2. I've got a couple of multimeter probes connected to it, and they did come included. So let's I've got some power going into it, so let's turn off again. Let's confirm what's in the capacitor. Yeah, 327. So let me see if I can get this in shot so you can see it, and we'll do the same again, and we'll watch the display on here. Yeah, you can see it going down on there and to nothing. The camera doesn't pick up the display very well, but I can see the reading quite clearly here. Let me check for voltage now. And again, yeah, it's managed to discharge it fine. So yeah, we've got 2 options now. I can use this one or this one. This one's a bit bulkier, and this one probably be the go-to one, I would say, just because it's dead cheap as well to buy, quick and simple. But if I'm struggling to get into certain places, then I've got this option, and I can use the multimeter probes as well. Nice to have both options available. This wasn't expensive either, to be honest. So yeah, 2 options, and now the capacitor's discharged, can work on that safely. Right, over to the curve tester. Now, I'm not going to get into this too heavy on this video because I'd like to do a separate video and really go through this in some more detail. But just as a demonstration on how it works, I've actually got two sets of probes in at the moment. So this is the A and this is the B side. I've got it set just to work on channel A at the moment. So across the graph here, we've got our voltage and on this axis, and then you've got your current on the upper axis. So if the leads are not connected, I will see that as a visual representation of a straight line. Now if I short my leads together, that will change and I will get a straight line on the screen. So it's really easy to identify because it's just giving you a visual representation, and components have different characteristics. So for example, this is a 330 ohm resistor, and if I test that against the leads, you can see that it gives you a slightly angled line, and that angle will vary depending on the size of the resistor. It will be more slanted than another. And if I test things like a diode, like here, you can see it drop off on that side, and if I rotate the diode around to test the other direction, you can see it change like that. Then we can test things like a capacitor. This is 100 microfarad, so if I clip on here, it becomes like a circle on the screen. Now let me just show you what happens if I connect two probes on here. Okay, so I've got my 100 microfarad capacitor just wrapped around the leads, and this one is a 10 microfarad on here. So this is power supply number one. If I've got two power supplies, one this side, one that side, I can switch to A and B mode, and you can see that I've got two lines on the screen now. So this line is with these leads and that line is with there. So now I can compare measurements, and if I do this capacitor, we can see, because it's a lot lower, it's only a 10, we've got a different visual representation on the screen here. So this is extremely useful if you're testing two boards, and extremely quick as well, because you can have your common ones grounded with alligator clips onto your board, and you just need two probes, and you can quite easily probe in this position, and go around your board and compare your measurements. Now I will want to make a further video on this and look at it in more details and actually try and use it to fault some kind of power supply. But yeah, as for now, just a quick demonstration of how it is. There are some caveats around using this because it is putting AC voltage into the circuit, so you wouldn't want to use this type of thing on like a laptop or something with some sensitive ICs on the board. But for just testing things like a power supply or maybe amplifier circuits, this is going to be quite useful. So yeah, that's it for this video. I hope you enjoyed it, and it was just a show and tell of those new tools that I've got. But I'd really appreciate your input. If you've got any advice regarding safety, any tools that you recommend, any channels on YouTube that you recommend checking out as well, please leave those all below in the comments, because that's what the channel's about learning, and I will read every comment that you put on there and check out anything that you say. So please leave it in the comments, and hopefully we'll be on the workbench soon giving it a go and trying to repair a few things, maybe some power supplies. So yeah, that's it for this one, and see you in the next.